thank you very much, Laura, and thanks to the organisers for inviting me. It's been really interesting morning listening to other talks. This is something a little bit different, although some of the threads from earlier speakers will carry through, I think. So I'm going to talk about, John Lewis gave me a bit of an introduction by saying, by mentioning the importance of certain metals, critical raw materials, and their importance in delivering a net zero economy. So the usual issues about getting, there we go. Just to say a bit, for those of you who don't know about BGS, British Geological Survey, we're the world's oldest national geological survey, and we have a centre, a big centre where I'm based in Nottingham. That's where I'm speaking to you now. We have another big office in Edinburgh, and we have offices in Cardiff and Belfast and in Wallingford in Oxfordshire. We advise government and civil society, industry, academia, the public. We do a lot of research in geoscience issues. We're a global geological survey. We work all around the world as well. Well, not at the moment, but we try to. And there's about 650 of us, of whom about 450, 500 are scientists. And we're part of UK Research and Innovation. So that's the ad out of the way. Critical raw materials, or raw materials generally, and Mark's talk early on the Anthropocene really picked up on this. What's driving demand? Well, what's driving demand is part of the energy transition, but it's mainly population growth and the aspiration of many people around the world, particularly in low and middle income countries, to become like we are and to enjoy the benefits that we enjoy. And one of those big benefits is urbanization, and urbanization really is the thing that drives big material demand. And I'll talk a little bit about that in a minute. It's not the subject of this talk, but it's hard to talk about critical raw materials without at least mentioning that. But for this slide, we'll just focus on low carbon systems. And the low carbon energy system, again, as John has mentioned already, it is material intensive. It requires quite a lot of materials. And the projections around our usage of materials, including metals, are going to grow, that they are going to grow very quickly out to the middle of the century. And that presents all sorts of challenges, again, most of which are not the subject of this talk, not least the amount of energy we expend producing metals. So obviously the UK has net zero ambitions, and we're one of the first of the richer countries to set these things down into law, and there's been a whole raft of initiatives and policy initiatives coming out of government over the last few years around how we power our net zero future, how we decarbonize our industries. And again, other speakers have mentioned these things. And the one I'll probably talk more about today than any other is a document that came out a couple of years ago called The Road to Zero, which is around how we decarbonize transport, which is like heat, it's another wicked problem that we have to solve here. And materials are a really important part of that. This focusing on critical raw materials, this is a really nice diagram which shows how not just the amount of materials we're using has increased since the beginning of the Industrial Revolution, but also the variety of the materials that we're using. So back pre-Industrial Revolution, we were using a very small number of elements from the periodic table, probably most of which we've been using since the Iron Age. And then as the Industrial Revolution progressed, gradually the palette of particularly metals that we use has increased, and as we went through the age of steam into the age of oil and the motor car, and finally to the place we find ourselves on the threshold of now, which is in terms of how do we deliver the energy that we need, how do we move around the planet in the way without putting more carbon into the atmosphere. And that requires a really broad palette of metals and other materials from the periodic table. And that presents us with all sorts of challenges in terms of how we obtain secure and sustainable supplies of these materials. Just to give you a flavor in terms of the relative amounts of these materials, because this is quite important in the way we look at critical raw materials. On this diagram, the critical raw materials really fit into they're on the right of the diagram as technology and precious metals, and they are mined in what I would say is relatively small quantities, even with the projections that we're seeing around increases in demand for these materials. They're still, relative to other things that we dig from the earth, we're still going to be using them in pretty small quantities. And you can see there that they fit when you compare those to the amount of aluminium we produce or the amount of chrome we produce, and then compare them again to the amount of iron ore particularly we produce. I mean, globally, the world produces about 1 billion tons of iron and steel every year, which requires about 3.5 billion tons of iron ore. That's actually dwarfed by coal production, which is somewhere between 8 and 9 billion tons per annum, which is a bit scary given some of the talks we've been hearing earlier today. So focusing back on the critical raw materials, we're producing these, although they're really, really important, we don't actually produce them in very great volume. And we're unlikely to, relative to other metals, what we'd call the industrial metals, produce them in any great volume, which makes them rather different in the way they behave to others, in that the production of them tends to get concentrated, and not just the mining of them, but also things like the refining and processing of them. And this creates problems in supply chains, because those supply chains are often although they may be long and global in extent, they're often, the production is in the hands of very few entities, different companies and different countries, and that can cause supply vulnerabilities. So just moving on to I'm a geologist, so it's nice to look at some rocks. Talk about one particular critical raw material, lithium. John mentioned lithium again in his talk earlier. Lithium's really, really important in delivering low carbon, zero emission transport, because we need that high energy density that lithium ion batteries give. And that will be lithium combined with metals like cobalt and nickel and things like graphite to manufacture those high energy density lightweight batteries that you need to put in cars and vans, basically. And our global lithium, what we call primary geological sources of lithium, currently comes from two main deposit types. One is pictured on the left there, my colleague Catherine Goodenough with an African counterpart, from what we call pegmatite rocks, which are a type of very coarse grained granite, which are enriched, many of which are enriched in lithium. And that's one source of lithium, what we call hard rock sources. And then the other big source is lithium brines, which currently all come from the very high Andes, the point in South America where the countries of Argentina, Chile, and Bolivia meet. And these are very high altitude saline lakes, which at depth have lithium bearing brines in them. And those brines are pumped and the lithium extracted them using solar energy. And as I said, those sources of lithium are then have to be, the lithium has to be separated either from the brine or from the ores, from the pegmatites, and it has to be refined, and the lithium hydroxide or lithium carbonate, which is a precursor chemical for battery raw materials, has to be produced. And as you can see, and this is very common with other critical metals, how much of those raw materials flow to China and Southeast Asia for processing. This is where currently most of the processing of these materials goes on at the moment. And then the Chinese, the South Koreans are selling us either refined chemicals or more likely battery cells or even battery packs for vehicles and things like mobile phones and laptops. Of course, where we're concerned about supply, and particularly where supply might be concentrated in one or two countries like China, then one of the natural responses to that is to look at our own resources, and can we produce lithium here? And John's already mentioned the possibility of producing lithium from geothermal brines in Northern England. And of course, that's also going on down in the southwest of England in Cornwall. The picture on the left there is of the big geothermal drilling site at United Downs. And there will be a pilot scale plant being established there with government funding to try and extract some lithium from the brines coming out of that development. What I would say about UK, I have to be careful what I say about UK domestic supply. There is some potential in the UK for lithium supply, but given the scale of the likely demand from our automotive sector, the UK is a big producer of cars, and that industry is transforming itself as we speak, particularly not least in Northeast England, into producing zero emission vehicles. It's unlikely that this domestic supply will come on stream for quite a while, for all the reasons that Stephen demonstrated on a smaller scale earlier. This is quite a risky business for developers, and I think that some of these things will take time to develop. And in the meantime, the UK needs to look at other sources of supply as well. We need to look at domestic sources, but we also need to look at other sources of supply. One of those sources of supply will be from recycling. I get a lot of people saying, well, why are we worrying about these things? Can't we just recycle them? Well, the answer is, in time, yes, we will be, but currently there simply isn't enough material circulating in the system. So putting aside all the technical, economic, and social provision you have to put in place to encourage people to recycle devices, to design devices that are easier to recycle, and to have all the commercial entity and the commercial infrastructure around recycling, all of which are really, really challenging. Currently, at the moment, there simply isn't enough material circulating in our systems for us to rely completely on recycling. What I'm absolutely not saying is recycling isn't important. It is really, really important, because over time it will grow in its contribution to supply. But currently, there are, relatively speaking, very few, for instance, electric vehicles on the road, and they're not. Most of them are not at the end of their lives yet. So in order to recycle something, you have to have a volume of it, and it has to be at the end of its life. Over time, as the number of electric vehicles increases, then we will see, and there's a lot of work going on at the moment about how this will actually work, the recovery of the lithium and the cobalt and the nickel from those batteries that those electric vehicles could contain. This is a message that we and colleagues in other geological surveys around the world and other institutions around the world and colleagues in academia are trying to get across, that in order to do all this, in order to deliver these materials that will enable us to deliver a low carbon economy, particularly low carbon zero emission transport, we need to understand the supply chains that are supplying these materials into our manufacturing sector. And these are very dynamic, they change all the time. But unless we understand them, we can't have effective policy or indeed encourage investment to intervene and mitigate these this raw material supply risk. And there's a lot of work going on in the UK and in Europe. The UK government's quite interested in this topic, and they ran a big conference back in February, which we participated in, on critical raw materials. It's a big topic for them. The UK has the G7 presidency this year, and it's a big topic within the G7 presidency that the UK is pushing forward on resilience of supply chains. And it's complicated. Materials move around the world, and they're subject to all sorts of different factors, which and challenges, environmental challenges, societal challenges, economic challenges, which certainly really affect the physical economy and how material stocks and flows, what material stocks are, and how that flows around the world. And it's really important we understand these local, national, and global systems for how these materials move around. And we've done some work. This is a nice Sankey diagram showing the flow of cobalt through the economy, the European economy, and it shows how complicated these supply chains are and where the losses are, where material flows in, where it's recycled, and this is the sort of work that needs to be done for all materials to try and understand where the best interventions are made to ensure that our supply is secure and sustainable and ethical. So to finish, is it possible to have secure and sustainable supply of critical raw materials to deliver net zero? I mean, the UK government has made a very strong net zero commitment, and it's also committed to maintaining our manufacturing status. So we will need access to a range of critical raw materials. And our belief in BGS is that we need to take a three-pronged approach to ensuring secure supply, and that's looking at domestic sources, global sources, domestic and global geological sources, and then we need to also look at recovering material from our own environment as secondary or recycled materials. Security and sustainability depends on finding and developing more capacity, both primary and secondary. So we need to keep looking for new sources in the Earth's crust of these materials. And we also need to look at ways of recovering, understanding how much is there and recovering more materials from our own environment, but recognizing currently that the mass balance is against us with recycled material. There simply isn't enough recycled material available to satisfy all our needs over the next 30 or 40 years. Security and sustainability of critical raw materials depends on understanding the supply chains and their vulnerabilities, and those vulnerabilities can come out of nowhere. I mean, you'll have seen on the news recently the issues around the Suez Canal being blocked by the Ever Given getting stuck in the middle there somewhere. We've seen big impacts on supply chains caused by coronavirus. We also see geopolitical issues coming along, like the trade war between China and the US. And all these human factors, if you like, and other environmental factors, and even health, global pandemics, really expose the vulnerabilities of supply chain. And that's why it's very important that we have some diversity in our supply, and also that we constantly monitor what's going on, so that if we need to intervene to solve a problem or to look for alternatives, then we can do that quickly. And on that note, I'll stop.
Thank you very much, Andrew.